Now let's talk about what it means to have left hand limit and what it means to have a right hand limit. So let's say I want to find the limit of x approaching 3. I must be able to find the left hand limit and the right hand limit. And when they're equal to each other, then we have a limit. We have an answer. So left hand limit will be written like this notation: limit of x approaching 3 from the left. From the left, we use a minus sign. For right hand limit, we say limit of x approaching 3. We use a plus sign. Let's say, for example, you did the math, and here you got 5, and here you got 4. Since they don't equal to each other, you say the limit of x approaching 3 does not exist because they don't equal to each other. Okay? But let's say they were both 5. You say the limit is 5. Okay? So you must always find left hand limit and the right hand limit.
But how do you find it?
How do you find it? Depending on the question. We'll do some questions. Let's show you what's called a piecewise function, which means it has two expressions or more. From the left-hand side and from the right-hand side. Okay? So this x is less than or equal to 3, left-hand limit. This x bigger than 3, right-hand limit. Okay? Right-hand limit. So how does this work? I'm going to say limit of x approaching 3 from the left for x squared minus 5 is equal to. Okay, you see, what I will do is I will simply replace the x with a 3. So I'm going to say 3 squared minus 5, which equals to 9 minus 5, which equals to 4. Limit of x approaching 3 from the right, for now it should be x plus 2. Replace the x with a 3. So 3 plus 2 is equal to 5. Are they equal to each other? No. So the limit of x approaching 3 does not exist because left hand limit and right hand limit don't equal to each other. Let's do another one. So here again, we have less than, we have bigger than. If it's less than, it's left hand limit. If it's bigger than, it's right hand limit. So right now, if they ask you to find the limit of x approaching 3 from the left, they're simply asking you to find the left hand limit of x squared minus 5. So 3 squared minus 5, which equals to 4. Limit of x approaching 3 from the right is 3 plus 1, which is 4. Now, because they're the same as each other, what do we say? The limit?
It exists.
Exists. And it's equal to 4. Okay, let's now do some trig functions. So here we have limit of x approaching pi over 4. 3 cosine of x. Now, do you know the cosine of pi over 4? You must know for the exam, it always comes back. The cosine of pi over 4 is the same as sine pi over 4, which equals to 1 over root of 2. So now you will simply replace the x with pi over 4. So you have 3 times 1 over the root of 2, which means 3 over the root of 2. Okay? Let's do another one. Limit of x approaching 0, 3 of times x over cosine. Now, 3 times 0 over cosine of 0. What's the cosine of 0? You must also know. It's 1. So 3 times 0 over 1, which means 0. Good?
Yes.
Okay. Let's now do a rational function. Limit of x approaching 0, 1 over x squared. If you were to replace that x with a 0, what do you think you will get?
1.
1 over 0 is infinity. Okay? So, right now, if I were to graph it for you using Desmos, because the denominator is squared, my left-hand limit and my right-hand limit will both approach infinity. Why? Look, on the number line, here is x equals 0, correct?
Yes.
Pick a number on the left of 0 that's very, very close to 0.
1.
No. Negative 0.001. On the right of 0, pick a number that's very, very close to 0. 0.001. Okay? Now, if I had a calculator, and if I plugged in one time 1 over negative 0.001 squared, and the other time I plugged in 1 over 0.001 squared, right? 1 over x squared.
Yes.
How much will I get? Let's see. I'll get 1,000,000 in both cases, actually. Yep. Which in math is a very huge number, or simply infinity. Let me show you what the graph looks like in Desmos. In Desmos, the graph would look like this. You see what's happening here? From the left side, we're going to infinity. From the right side, we're also going to infinity. Both sides are approaching infinity from left and right. But here's the catch. They will never touch x of 0. It seems as they're afraid of touching x equals 0. Because if you have x of 0 in the bottom, you're going to have 1 over 0 squared. Having a 0 on the bottom means you have vertical asymptote. Vertical asymptote at x equals to 0. They're afraid of x equals 0. They might approach it, but they will never touch that vertical line. So, anytime you end up with a 0 in the denominator, you essentially end up with a vertical asymptote. For example, if I have 1 over x minus 3, what number will make that denominator 0? What number?
0.
No, what number, if I put for the x, will make the bottom of the equation 0?
3.
Exactly. Vertical asymptote at x equals 3. Let's draw that. Now that's drawn, what do we see? We see that from the left-hand side, we are approaching negative infinity from the right hand side, we're approaching positive infinity. Okay? So left hand side and right hand side are not the same as each other. We say the limit does not exist. Because you would say left hand limit is not the same as the right hand limit. Let's now do another one. Limit of x approaching 0, 1 over x. Let's assess it from the left of 0 and from the right of 0. Pick a number on the left of 0 that's very close to 0.
0.00.
Negative 0.001 and 0.00. So left hand limit 1 over negative 0.001, negative 1,000. Right hand limit 1 over 0.001, which is 1,000. So negative infinity versus infinity. So do we have a limit? No. The limit does not exist. Does not exist. We have a vertical asymptote at x equals 0. Because right now, if you want to make that denominator 0, just put 0 on the x. Let's do this problem. Limit x approaching 2, x plus 2, x squared minus 1. So here in this situation, you would simply replace with 2. And you get 2 plus 2. You get 2 squared minus 1. You get 4 times 3. And you get 12. Limit x approaches 10. X squared minus 7x minus 30 over x squared minus 12x plus 20. Right now, if I replace every x with a 10, I'll get 0 over 0, which they don't like.
Yes.
So instead, you will factor 2 brackets on top, 2 brackets on the bottom.
Yes.
X squared, x, x, x squared, x, x.
Yes.
What's 30 made of? What times what? So 30 is made of 6 times 5. And how about 20?
3 times 5.
No, it's actually 2
Oh.
times 10. Let me ask you a question. What's 6 plus 5?
11.
Okay. What's 6 minus 5?
1.
But this is negative 7x. So it's not 6 times 5. Try different numbers. 30 is made of what? You said 6 times 5. That was correct. What else?
3 times 10.
Exactly. So 3 and 10. Since here you have negative 7, should you do 10 minus 3 or 3 minus 10? It's negative.
3.
Minus 10. So a positive 3 minus 10. Okay. Now here, if you were to do 2 plus 10, what do you get? 12.
Yes.
But this is negative 12. Do you know what that means? It's negative 2, negative 10. Now you can cancel them. If you cancel it, what do we call it? Removable discontinuity at x of how much? 10 or negative 10? Always change the sign.
Positive 10.
So now replace every x with a 10. So 10 plus 3.
10 minus 2.
So 13 over 8. Let's use Desmos and see what that looks like in a graph form. I'm going to grab this guy here in Desmos. So here's the graph with the table. It seems that there is this vertical asymptote at x of 2 according to the graph, right? So if they give you this graph and it looks like this, it seems that the red ones do not touch the blue one. Okay, this is 2. Okay, but let's go on to what we canceled. We canceled x of 10. Let's see if our function is defined or not at that point. So now, as you can see, when I write x is equal to 10, I also get undefined because we removed it. Okay, we removed it. Now let's do limit of x approaching infinity, 1 over x. So here I have no choice but to replace the x with infinity. What's 1 over infinity? What's any number over infinity? 0. So the answer is 0.
That's it.
It's that simple. What if I want to find the limit of x approaching negative infinity? Replace the x with negative infinity, I still get 0. It's that simple. It's that simple. Okay, let's do more. Let's now do the limit of x approaching infinity for 3x plus 5 over 7x minus 2. Whenever you have x approaching infinity, okay, and if the exponent of the x on top is the same as the exponent of x in the bottom, your answer is going to be the coefficient of those two. So what's the biggest exponent of x in the numerator?
7.
No, exponent. It's 1. How about denominator?
1.
So 1. That means just pick your coefficients. So 3 over
7.
is going to be our answer.
That's it.
That's it if you have x approaching infinity and if you have numerator and denominator having the same powers or the same exponents. Okay, very good. But this is called the MCQ answer. If you have to show your work, which is the FRQ answer, let me show you how it's to be done. You will divide everything on top and the bottom by the highest power of x in the bottom. So what's the highest power of x in the bottom?
1.
Yes, x to the power of 1. Divide everything by x to the power of 1, which means divide everything by x. So you're going to have 3x over
7x.
x. No, just the x. Plus 5 over x. 7x over
X.
x. Minus 2 over x. And now, what's 3x over x going to give you? It will give you 3. What's 5 over x going to give you? What's 5 over infinity? 0. Any number over infinity will give you a 0. 7x over x, just 7, right?
Yes.
And minus 2 over infinity will give you 0.
0.
So 3 over 7. And by the way, since I already replaced in here, I don't need to write this guy anymore. You only write limit of x approaching that value is before you start to replace. Our answer comes out 3 over 7 in the FRQ way. Same as the MCQ answer. Let's do more. So now my question to you is, in this question, what's the biggest exponent of x in the numerator? 2.
2.
What's the biggest exponent of x in denominator? Also 2.
2.
Because they're the same, just divide their coefficients by each other. So 8 over 16, which means 1 over 2.
That's it.
That's for the MCQ.
Okay.
For the FRQ, what you do is you divide everything by the highest power of x in the denominator, which is x squared. So divide everything by x squared. So you're going to have limit of x approaching infinity, 8x squared divided by x squared, minus 4x divided by x squared, plus 1 divided by
X squared.
x squared. 16x squared. You get the idea. But now the follow-up work is not the easiest. We should be careful. So, the trick is, whenever the exponent of the x is larger in the denominator, that whole thing becomes 0 when x approaches infinity. So, 8x squared over x squared is an 8. But for the next ones, since the exponent is bigger in the bottom, the whole thing becomes
0.
0. 16 plus 0 over 2. And that's how we do it. Let's do another one. So here, the highest exponent of x in the numerator is what?
10.
How about the denominator?
10.
Because they're both the same, just divide their coefficients by each other.
Yes.
So negative 3 over 33, negative 1 over 11 would be the answer. Now let's do more. For this one here, if you were to put every x as 0, as 9, you get 0 over 0, which is not okay. So don't do that. So what do we do instead? Do you know? It's called factoring. You factor. So we're going to have x here, x here, x here, x here.
Yes.
That 45 is made of 9 times 5.
Yes.
That 18 is made of 9 times 2. How about the signs? If you do 9 minus 5, you get 4. But here we have negative 4.
Yes.
So what do? You do plus 9, you do minus 9 plus 5.
Why?
To give you negative 4. And here you have negative 11. That means you will do negative 9 in addition to or plus negative 2. Anything in common?
Negative 9.
X minus 9
Yes.
gets cancelled.
Yes.
That means we have what? A removable discontinuity at x equals 9. Now simply replace every remaining x with a 9.
Yes.
So we're going to get 14 over 7, which is 2. Let's do more practice. Limit of x approaching to 8 over x minus 2. Is there any way to save that denominator from becoming a 0? No way. There is no way. And right now, if you plug in 2 in the bottom, what happens? What do you get in the bottom? You get 0.
Yes.
That means you have vertical asymptote when you plug in 2. That's what it means.
Yes.
Okay? A vertical asymptote when you plug in 2. Now, if they want the limit, you will give it to them. How? This is x of 2. Think of a number that's very close to a 2 from the left. 1.999. Think of a number that's very close to a 2 from the right. 2.001. Now, let's plug in. So we're going to have 8 over 1.999 minus 2 versus 8 over 2.001 minus 2. If you were to use the calculator, you will get a big negative number for the left, which means I will call it negative infinity. And for the right, you will get a big positive number. I'll call it infinity. Are they equal to each other? No.
No.
So we're going to say that the limit does not exist. Okay.
Okay.
Let's do more practice. Limit x approaching 2, 8 over x minus 2 squared. Take it from me as a rule, whenever the power of the denominator is even, you will always have a positive answer. Always. Now, question. Can you salvage the bottom from becoming a 0? Can you factor anything out here? No. So right now, if you were to plug in x of 2 in the bottom, you get 0, correct?
Yes.
That means there's a vertical asymptote at x of 2. Now let's move on to our limit. Think of a number on the left of 2 that's very close to a 2. 1.999. On the right, 2.001. If you were to plug in those numbers in this equation, you will get the same answer, by the way. Both of them will give you a big positive number, which is infinity. So now you have a choice to either say the answer is infinity or to say it does not exist, because infinity is not a real number. It's your choice. Let me now ask you a question. Limit of x approaching 0, 1 over x squared. What's the answer? Right now, if you plug in 0 here, you effectively made the bottom of the equation 0. That means you have vertical asymptote at x equals 0. And since the bottom of the equation has an even power, you will always get positive infinity. So now you can say your answer is positive infinity, or you can say your answer doesn't exist. It's your choice, because infinity is not a real number. Let me show you what that looks like on the graph. We're going to write 1 divided by x squared. You see those two graphs from the left and the right? Do they both head in the same direction?
Yeah.
The direction of infinity. They are both heading toward infinity. But there's one thing that's noticeable about this graph. You can notice it very well. Are they afraid of touching a certain vertical line?
Yeah.
Which one?
0.
Exactly. Right now I can put x of 0 here between them, and they're going to be so afraid to touch it because it's a
Yes.
vertical asymptote. Okay. Let's do more practice. What's going to be your answer for this one? Right now, if I were to plug in that 3, I'll get 0 on the bottom. That means I have vertical asymptote at x of 3.
Yes.
But 3 So my left-hand limit will be when I plug in x of 2.999. My right-hand limit will be when I plug in x of 3.001. That means my left-hand limit is negative infinity. Right-hand limit is positive infinity. Are they equal to each other? No. So my limit does not exist. Okay. Let me show what that looks like on the graph, by the way.
I just need to practice.
Everyone needs to practice. Do you see the graph?
Yeah.
They seem to be going away from each other. One heads positive infinity, one heads negative infinity. Are they afraid of a certain x value between them?
I don't know.
They are. They will never touch this x value. They will never touch it. It's at 3. X equals 3 is our vertical asymptote. Let's now do another example. If I were to replace every x with a 1, I'll get 0 over 0, which is a crime in calculus. You're not a criminal, so don't do that. Now, I want you to factor. Do you recall how to factor a squared minus b squared?
Yeah.
What's the answer to that?
2 brackets, 1 negative and the other positive.
Perfect. So 1 times x minus 1, 1 times x plus 1
Yes.
over x minus 1. Remove them.
Yes.
Removable discontinuity at x equals to
1.
1. In a test, if you're given a graph, this would appear as a whole in that graph, as a whole. Okay? Okay. Now, you can now simply substitute, right? So you're going to have 1 plus 1, which equals 2.
Yes.
Easy. Not that hard.
Yeah.
Okay. Let's do more. Let's do the limit of x approaching infinity, x squared plus x over 3x squared minus 1. When x approaches infinity, you must find out if the top and the bottom have the same highest exponent of the x.
Oh.
As of now, do they? They do.
Yeah.
They're both 2. That means just divide their coefficients by each other. So 1 over 3. But that was pretty easy, right?
Yes.
Okay. Let's see when the powers don't equalize each other. Limit of x approaching infinity, x squared plus x, 3 minus x. Here the powers don't agree.
Yeah.
So now what you do is you divide every single thing, top and the bottom, by the highest power of x in the denominator. What's the highest power of x in the denominator?
2.
No, it's 1. So divide everything by x to the power of 1, which is just x. So you're going to have limit x approaching infinity, divide everything by x, x squared over x plus x over x, 3 over x minus x over x. So x squared over x will give you what? Do you know? X. X over x, 1.
1,
3 over x,
3,
actually 0. Any number over infinity is 0. X over x is 1. So you can have infinity plus 1, 0 minus 1. You can have infinity over negative 1, which means negative infinity.
I'm confused.
Why?
Um,
Okay, so let's just recap it then. Okay, we said when the highest powers of the top and the bottom don't match, divide every single thing by the highest power of x in the bottom. As of now, the highest power of x in the top is 2, and in the bottom is 1. The powers don't agree. Divide everything by the highest power of x in the bottom, which means divide everything by x. So limit approaching infinity, x squared over x, x over x, 3 over x, minus x over x. Okay. What's x squared over x? Just x. What's x plus x? 1. What's x over x? 1. If you divide any number by infinity, you get 0. So that means 3 over x is just 0. X plus 1 is infinity plus 1. Infinity over negative 1, negative infinity. Okay?
okay.
More. Limit x approaching infinity, 3x squared minus x minus 2, 5x squared plus 4x plus 1. So whenever you have x approaching infinity, look for the highest exponent of x on the top and the bottom. If they match, which they do, just divide their exponents by each other. So 3 over 5.
That's it?
Yes, but that's only for the MCQ. For the L4Q, you must actually show the work by dividing every single thing by the highest power of x in the bottom, which is x squared. So you're going to do limit, x approaching infinity, 3x squared divided by x squared minus x divided by x squared minus 2 divided by x squared, 5x squared divided by squared plus 1 divided by. Now, let's see. Limit x approaching infinity. 3x squared over x squared is just a 3.
Yeah.
Minus x over x squared, 1 over x. 2 over x squared. 5 plus 4 over x. 1 over x squared. Now, whenever we divide a number by infinity, the answer becomes 0. That means we'll have 3 minus 0 minus 0, 5 plus 0 plus 0. So 3 over 5 is going to be our answer. Good.
Yes.
Let's now work with absolute values. So the limit of x approaching 0, absolute value of x over x. When it comes to absolute value, you must always break it down using a piecewise function. Absolute value, piecewise function. Meaning, you must do the following. You say it's negative x if x is less than 0, and it's positive x if x is bigger than 0. So if it's less than 0, left hand limit. Bigger than 0,
Right hand limit.
so we'll do left hand limit. Limit of x approaching 0 from the left. And instead of the absolute value, just put minus x of x. And for the right hand limit, limit of x approaching 0 from the right, plus x over x. Here you get negative 1, here you get 1. Left hand limit, right hand limit, are they the same as each other?
No.
No, the limit does not exist. Let's see what that would look like in a graph form. So we're going to write absolute value of x over x. Look at the graph. What do you think of it? Do you see a jump in the graph?
They're opposite of each other.
Look, it seems the graph was going this way
Yeah.
and then jumped.
Yes.
This is what we call a jump discontinuity. Jump discontinuity. They jump at what x value?
0.
0. Exactly. So because there's discontinuity x of 0, the limit does not exist. Yes.
Okay.
Yes. Because the left-hand limit is negative 1. And the right-hand limit is positive 1. Not the same, does not exist.
Yes.
Let's talk about something new called oscillating functions. So if the question says find the limit of x approaching 0, sine of 1 over x. Okay, let's use Desmos to look at the behavior of the function. So in Desmos, go to functions, sine 1 over x. Okay, right now we're looking at x of 0. Do you see oscillation at x of 0? The function is as low as negative 1 and as high as 1. That's called oscillating function or behavior, which means that the limit does not exist. So the limit of x approaching 0 does not exist due to oscillating behavior. Okay? Right. Now let me show you what that looks like in a table form. So go to this guy here, table, and let's be very close to 0 from the left. So I'm going to go with negative
0.001.
negative 0.001, and let's go close to 0 from the right, very close to it. So 0.001. Look at these values. Look at how different they are. From negative to positive. This means we have an oscillating behavior. Limit does not exist. That's what it means. Okay. Let me show you that in a table form from the document itself. This problem here, we have limit x approaching infinity cosine 2x over x squared. Okay, so typically it will be very, very wrong for you to place infinity and try to find cosine infinity. That would be very wrong. So what method do you guys think we should be doing here? Any clue as what to do? Shall we just ask the calculator what cosine infinity is? Try it. Try using this calculator here. Just put cosine of a million and let's see how much. So see how much you get. Cosine of a million. Okay, that's 1,000. Put a million. Yeah, 6 zeros. Okay, so anyways, it gets to, thanks so much. It gets to a very large number at some point, or a very small number in your case. Typically, never put cosine of infinity at all. Now, let's look at the behavior of cosine 2x on Desmos. Let's see the behavior of cosine 2x. So go to functions, cosine 2x. What do you guys see? We see oscillation from what value to what value? From -1 all the way to +1. If you have an oscillating behavior, can you say the limit exists? So the limit does not exist as long as we have this oscillating behavior right now. But right now we know that cosine 2x ranges from -1 to 1. That's a start. So we're going to say cosine of 2x ranges from -1 to a 1. Now, can we rewrite this equation as limit of x approaching infinity 1 over x squared times cosine 2x? Would that be the same thing? Same thing, right? Because if I have 4 over 5, it's same thing as 1 over 5 times 4, correct? So, right now, what I will do is, I will multiply everything that I see in here by 1 over x squared. So, what's -1 times 1 over x squared? -1 over x squared. What's cosine 2x times 1 over x squared? Cosine 2x over x squared. What's 1 times 1 over x squared? 1 over x squared. Now, in the question, x is approaching what value? Infinity. X approaches infinity. So you're going to have now to replace x with infinity. We're going to have -1 over infinity. Cosine 2x over x squared. Don't touch the middle term, only the ones on the edges. 1 over infinity. What's -1 over infinity going to give us? Do you guys know? 0. How about the other one?
0.
0 as well. So we're going to go back and we're going to say our answer is going to be 0. This was an example of using the squeeze theorem. Second example so far in the book. Any questions about it? Okay. Let's now talk about something new called discontinuities. which we mentioned to a certain degree last time, if you guys recall. We have multiple types: removable, jump, and essential. Essential is also called a vertical asymptote. Okay. So if it's removable, it's going to appear as one graph with a hole in the graph. If it's jump, it's going to basically be two graphs that are disconnected from each other. If it's a vertical asymptote, that means that they're going to be afraid of touching a vertical line. They could look like this, or they could look like this. Afraid of touching a certain vertical line in the middle. Okay, we have three types of discontinuity. So what does it mean to have a discontinuity? It means one of two things. So to have a discontinuity, it means one of two things. Either the limit does not exist, or the limit exists, but it's not equal to the function at that specific point. Let's discuss each condition separately. So, when does a limit not exist? When the left-hand limit and the right-hand limit are not equal to each other. Okay, that's condition number one. Condition number two is when the limit exists, but the limit is not equal to f of c. So for example, the limit as x approaches c is equal to a certain number. Let's call it k. But then when you plug in f of c, you don't get k. So for example, maybe the limit is equal to a 5, but the function at that same point is not equal to a 5. Maybe it's equal to a 4. So either this condition or that condition would make a function not continuous, which means discontinuous. If you guys look at your book, what do you see? What discontinuity is this one called? I don't know. I think it's 98. Okay. Whenever you see two graphs that have been disconnected from each other, we call it jump discontinuity. Let's interpret what we're seeing right now. When it says there's a hole, what does that mean? A hole means that the function is not defined. How about a dot? The function is defined. Please know what these terms mean. Important for the MCQ part. So, a hole, function is not defined. A dot, the function is defined. Okay? Very important. So whenever you see two graphs that are not connected to each other, we call this a jump discontinuity, which basically means that the left-hand limit is not the same as the right-hand limit. If your left-hand limit is this value, your right-hand limit is this value. They're not physically touching each other. They're different from each other. Limits don't equal to each other. Now, let's talk about another one here. Look at the other graph. We have this curve here, and we have this other curve here. Do you feel like they're afraid of touching a certain vertical line? Yes. They're afraid of touching x is equal to a certain value. That means that we have a vertical asymptote at x is equal to a certain value. Okay? How about this one here? This one is going up. This one is going up. Are they physically touching each other? No. They're afraid because there is a separator line in the middle called a vertical asymptote. Having a vertical asymptote is called essential discontinuity. Essential. How about when it's removable discontinuity? When you remove it, you remove something. Removable discontinuity. Something had to be removed. Okay? So what's happening here is that left-hand limit is equal to the right-hand limit. But you see there is a hole. That means the function is not defined at this point. The function is not defined at this point. A hole means not defined. So look, if the limit of x approaching a certain value from the left is equal to the limit of x approaching a certain value from the right. Okay, so negative means left, positive means right. In this case, does the limit exist? Yes, the limit exists. So condition number 1 is satisfied. The limit exists. But that's not enough for the function to be continuous. Okay? To be continuous, you must have the limit as x approaching a is equal to the function when x is equal to a. That's called the second condition. When both conditions are satisfied, only then the function is going to be continuous. So you must always have two conditions. The limit exists, and that limit is equal to the function at that specific value. For example, if you guys look at the book, if there is a hole, is the function continuous? No. A hole means that the function is not continuous. But if there is a dot, the function is what? Continuous. All right, guys? Dot means continuous, hole means not continuous. All right? Let's go ahead and do an example of a piecewise function, which means a function that's made of two parts. F of x is, first part is x plus 3, when x is less than or equal to 2. Second part is x squared when x is bigger than 2. Whenever it's less than, that's called left-hand limit. Whenever it's larger than, that's called the right-hand limit. Now, I'm going to ask you guys to find the left-hand limit and to also find the right-hand limit and to see if they're going to be equal to each other. So go ahead and replace. You guys must have learned this last time, if you remember. You guys need help? I can help. Okay, so look, for left-hand limit, we're going to do x plus 3, but instead of the x, put 2. So you're going to say 2 plus 3, which equals to 5. For right-hand limit, it's going to be x squared, but instead of x, put 2. So 2 squared is equal to 4. So left-hand limit is not the same thing as right-hand limit. If that's the case, the limit does not exist. If the limit does not exist, the function is not continuous right away. Okay, the function is not continuous. Why? Because of something called a jump, discontinuity. Whenever the left-hand limit is not the same as the right-hand limit, we call this jump discontinuity. Jump. Because your graph is now experiencing a jump. That's why. Okay? If you guys look at the book, the graph is going to be experiencing a jump. Okay? So on the book, the graph looks like this. Then it jumps. Let's analyze what's happening. Who knows where the left-hand limit is? You're going to it from the left. So this is the left-hand limit. And this is the right-hand limit. Are they meeting up? No. So they're going to be not equal to each other. Is your graph made of two segments or one segment? Two. That's why it's called jump. Your graph simply had to jump. Okay, let's see what's happening here. There is a hole here because there is no equal sign. But there is a dot because there's an equal sign. Let's look at our piecewise function. There is an equal sign here. That's why there is a dot. But there is no equal sign here. That's why it's a hole. Makes sense? That's how you read the graph. You can do that correctly, you can get the 5. Okay. Let's do more. Let's make you another piecewise function. Here we have our piecewise function. Okay. If I want to find the left-hand limit, which part of the equation do I use? And how about the right-hand limit? Which part of the equation do I use? Can you guys tell us? Who is brave enough to tell us what to do right now? Okay, so whenever you have not equal to, that's going to be both your left-hand limit and also your right-hand limit. Please make this a rule. Write this somewhere. This means both limits are the same, left and right. So that means we're going to be having x squared here, and again, x squared here. Instead of x, put 2. Instead of x, put 2. So 4 and 4. So both limits, left hand and right hand, are both equal to a 4. Both. Okay. So now we know that the limit as x approaches 2 from both sides, left and right, is equal to a 4. The first condition has been met. How about the second condition? When x is equal to 2, how much is the y? Can someone tell us? That's not too hard. When x equals 2, y is equal to 5. So now my question to you is the limit the same as the value of the function at 2? Or are they different? One is 4, one is 5. At least tell me, are those the same number or different numbers? Can you guys answer that at least? Okay. So they're different numbers, right? So the limit as x approaches 2 is not the same thing as f of 2. So the function is not continuous. Let's look at the graph. If you guys look at the graph, is the graph made of 2 segments or 1 segment? Where's the other one?
No, it's all because there's
1 segment. If your graph is not segmented at the hole, we have this type of discontinuity. Because your graph is made of one thing. There is no jump at the hole. Your graph is not cut up. Is not cut up. Okay? So whenever the graph is not cut up, you have this type, and also you have the left hand limit is equal to the right hand limit at this point. But the hole itself means your graph is not continuous. Okay? This is hard. If it's too detailed, we have lots of details written for you in the Khalid sheets. 31 pages of information. So you guys can look at that at some point. Okay. Can someone tell us why is there a hole and not a dot? Can someone tell us why is there a hole?
It's not defined.
Can we tell that from the piecewise function? Yes, we could. Not equal to. Not equal to means there's going to be a hole. If you guys look, if you see not equal to, if you see bigger than, if you see less than, all of these things will give you a hole. But if you see equal to, bigger than equal to, less than equal to, you get a dot. A hole means not defined. Dot means defined. Let's do more. How about this one? Is it continuous at all x's or is it not at some x's? What do you guys think? If right now I place a 2 in the bottom of the function, what's going to happen? I'll get a 0 on the bottom. Is that okay to get a 0 on the bottom? No. So right now if I place a 2 in the denominator, I'll get a vertical asymptote, which is not okay. Not okay. Okay? So right now if we graph this in Desmos, we're going to get the following. And go ahead. 5 over x minus 2. Is the graph afraid of touching a certain value? It is, right? They're afraid of touching what vertical line? This one here. Can extend vertically up and vertically down, and the green curves will never touch it. There's a vertical asymptote at x of 2. So the limit as x approaches 2 from the left is equal to the green line is going vertically down and getting larger. That's called negative infinity. And the limit as x approaches 2 from the right is getting bigger in the positive region, infinity. Okay. A vertical asymptote at x of 2. We call this an essential discontinuity. Let's do another one. How about this one? The question comes in the exam and they ask you, at what point is the function not continuous? What do you tell them? Doesn't matter. How do you go about solving this question? But that was, so I know what you're doing right now. You're finding the limit of x approaching infinity. But we're not saying that here. It's not told to us, so we cannot do that, no. This question comes in the exam, easy points. What do you guys do? You factor, exactly. Whenever you see a quadratic function, always factor. Always factor if you can, okay? Yes.
Okay. So x minus 3 and x minus 5
Mm-hmm.
and x minus 3.
How much?
3.
5 is made of what times what?
5 is 1 point.
1 times 5.
Yeah, 1 times 5.
So 5 and 1. And they're both negative because if you add -5 to a -1, you get -6. Now it's time to cancel x minus 5 with x minus 5. If you canceled it, you removed it. Correct? We removed it. At x equals how much? Exactly. That means you will have a hole when x equals to 5. There's going to be a hole at x equals to 5. Okay? So, that's how it works. Now, our function is going to end up being x minus 3 over x minus 1. What x value, if I were to place in the bottom of the function, will make the whole thing 0 on the bottom? 1. That means I have a vertical asymptote at x of 1. So I have two things, right? At 5 and also at 1. All right? Okay. Let's do more. So on this question, is the function continuous at x equals 2? So, if it's less than left hand, bigger than right hand. Left hand limit, x plus 1, and instead of x, put 2. Right hand limit, 2x minus 1, and instead of x, put 2. So, good news, limits are the same as each other. So limit as x approaches 2 from the left is same as the limit from the right, which equals to 3. That's good news so far, right? But is the limit the same as the function? What's the function when x is equal to 2? Which one do I use? Do I use less than? Or do I use bigger than equal to? If I want to find f of 2, which one do I use? Less than or bigger than equal to? Always use the equal sign one. Always. So to find f of something, always use the equal sign notation. That means to find f of 2, I must use the bottom one, which is 2x minus 1. Why? Because there's an equal sign in here, that's why. So you're going to have 2x minus 1. And instead of x put 2, we get 3. So, the limit of x approaches 2 is equal to the function at 2, which equals to 3. So, the function is continuous. Okay? So, two things have to be met. The limit has to exist, and the limit must be equal to the function. which means they're both 3 in our case. Function is going to be continuous. Okay. Let's make another example here. A piecewise function again. So is the function continuous at x equals 2? So because I don't see an equal sign, the function is not defined at x equals 2. So the function is not continuous at x equals 2. Easy, without doing any work. Let's give you another question now. How about this one? Can someone tell us where the left-hand limit is? Less than means left-hand limit, and bigger than means right-hand limit. Go ahead, start working on it. So the left-hand limit
It's 3.
is 2 plus 1, which is 3. The right-hand limit, 5. Not the same. So the limit does not exist. So the function is not continuous. Okay. So where is my left-hand limit? Less than. Right-hand limit? Bigger than. Are they the same as each other? How much? 3 and 3. So the limit as x approaches 2 from both sides is equal 3. The question now is, what is the f when x is 2? So are they the same as each other? No. So the function is not continuous at x equals 2. This question comes up in the AP. What do you do?
So is that for absolute value?
Yeah. If you see absolute value, always break it up into a positive component and a negative component. So your left-hand limit is going to be when the absolute value is all negative from the outside. Right-hand limit when it's all positive from the outside. So to assess your left-hand limit, which means the limit as x approaches -7 from the left, would be to place -x plus 7 in the bottom of the function. Because left-hand limit means negative on the absolute value. This will never change, by the way. And now you just have to cross them out and you get -1. The limit when x approaches -7 from the right side will be to place the bottom of the function with the positive absolute value, which means if you cross them out, you will get a 1. So since those limits are not the same as each other, we have what we call a jump discontinuity. So we're going to say left-hand limit is not the same as the right-hand limit, and we have a jump discontinuity. Okay? Good. Okay. How do we solve this one? Whenever you see a quadratic, what do? You factor. So please factor the numerator and let me know what you get. Very good. So what do we have right now? We removed it. It's been removed, right? At what x value? Can someone tell us? Exactly. That means your graph must have a hole. Must have a hole. If the examiner gives you a graph, it's going to have a hole in the graph. Okay? So yeah. Okay. You see? You're going to have a hole at x of 2 because you removed it. Okay? Let's look at this one. You see when x is not equal to 2, that's a hole. When x is equal to 2, that's a dot. The dot and the hole, are they meeting up? No. So it's not continuous. Because they don't meet up. Okay, not continuous. Let's see if you guys can do this one. Go ahead. Example 5. Alright, so bigger than means the right hand limit. Less than means left hand limit. So root of 4 minus 4, which equals 0. 8 minus 2 times 4, which equals 0. They're the same. The limit exists. Because they're the same. They're both 0. Very good. Let's do example 6. When they want you to assess the limit of x approaching 1, which one do you use? The top or the bottom of the piecewise function? Top. It must be not equal to. Always. Always. So what do? Just replace x with 1. 1 plus 1 is equal to 2. And that's about it. The answer is correct. Okay. Let me show you the graph of this one. You see? You're going to have a hole because x does not equal to 1 at this point. And here, if you guys look at it, when x is 1, g of x is pi, which means 3.14. So when x is 1, g of x is almost 3, 3.14. Okay? Good. Now, when it comes to vertical asymptotes, please know this notation. They love it for the MCQs. Limit of x approaching a certain number from the left is equal to that limit as x approaches from the right. Okay? The limit does exist. And the limit is going to be either equal to positive infinity or negative infinity. Please know this notation very, very well. Okay. Let's see if you guys can solve this one. So this one here looks like a squared minus b squared. So a minus b times a plus b. So x minus 3, x plus 3 over x minus 3, x plus 2. So these will cancel. So we're going to have x plus 3 over x plus 2. Okay. Now, what's my vertical asymptote? What number will go on the bottom and make the whole thing 0? -2, right? So vertical asymptote at x is equal to -2. All right. How about this one here? You must factor both top and the bottom. Go ahead.
Did we do this one?
Maybe. Have we?
Yeah.
X minus 5, x minus 3, x minus 5, x minus 1. Yep. So vertical asymptote at x is equal to 1. Okay. Find the place of each discontinuity in the graph. In example 9. Wherever there is a hole, it's not continuous. So where are the holes right now? X equals 1, 3, and 5. Tell me their types, please. If the graph is connected, we call it If the graph is disconnected, very good. Okay. Take your time on example 11. Whenever you see absolute value, what do? One time negative, one time positive. So as x approaches 0 from the left, you will do the negative. As x approaches 0 from the right, you will do positive.
We do have -0.
Yeah, so it's just 0. So -0 is just a 0. 0. So because they're the same, limit is equal to 0. Okay? Yeah. All right, go ahead and find all the possible places where the function is not continuous. At what x's is the function not continuous? So, if you factor, you get x minus 9, x plus 5, x plus 5, x plus 2. They cancel. Add -5 and also a vertical asymptote at -2. So 2 types. The book here made a mistake. Okay. Okay. How about this one? What do we do here? No. If you put 3 in the bottom, the whole thing becomes 0. Correct? What's the limit as x approaches 3 from the left? You guys know? This is 3. Choose a number on its left that's very, very close to it. So you get -infinity. On the right, 3 point. So from the right side, you get positive infinity. Okay. Very good. Now we have something new called horizontal asymptote. It's different from the vertical ones. Just like the vertical ones, you must have a rational function, which means numerator and denominator. If you guys look at the rules in the book, they say if the highest power of x is in the numerator, the limit when x approaches infinity is infinity. So, how do we assess horizontal asymptotes? Limit x approaching infinity. Imagine if we have x to the power of n in the bottom, but the top has x to the power of n plus 1, which means the bigger power is on top. You get infinity. Okay? What if the bigger power is in the bottom? You get 0. What if they have the same exact powers, but they have coefficients, maybe 2 and 3? You just have 2 over 3. Okay? 3 rules for the horizontal asymptote whenever x approaches infinity. Let's do an example here. So the limit of x approaching infinity, 5x7 minus 3x, 16x6 minus 3x squared. So here the bigger power of the x is in the numerator. 7 is bigger than 6. You get infinity. We say that there is no horizontal asymptote if the answer is infinity. Let's do another one. How about this one?
0.
Yes, because the bigger power of the x happens to be in the bottom of the function. So you get 0. The bigger power is 7. Here it's 6. Bigger on the bottom, you get 0. You guys get the idea. G of x is equal to 1 plus x squared, 1 over x squared. Okay, and I want you to approach 0. X must be approaching a 0. So I'm actually going to allow you to use Desmos for this one. Let's assume that this is a graphing calculator equation. So please use Desmos and plug in Desmos and let me know how much you will get.
Someone said undefined?
Plug in Desmos, please.
Where's Desmos? Where do we have in our phones?
You do? There's not. So the function is going to be y is equal to, it was gx, same thing, bracket 1 plus x squared, close bracket, and then to the power of 1 over x squared.
How do you get
That's what you do.
And it's set as x approaches 0, right?
2.80 something.
Here, it's right here.
So I don't,
Now it says when it's 0, it's undefined, correct?
how do I get
Yeah.
But look at the left and look at the right. Are they both approaching the same value, which is 2.7 something?
Yes.
And if you want, you can click on this thing here, click on table, and you can put a number that's very close to 0 from the left.
So how can I put the power of 2?
And let's try, what number can be left of 0?
-1.
No, very close, negative 0.001. On the,
How can I do this here?
and now let's put a number that's on the right of 0, but positive, so 0.001, and again it's 2.71. So you see what's happening here? From the left-hand side and the right-hand side, we're approaching the same number.
How do I get the table of 0?
There's graphic on this calculator. correct?
There's, but Desmo is much faster, honestly. So you can say that left hand limit is equal to the right hand limit. Okay, when the limit
Mister,
of
for me, it doesn't say 2.7, it just says 2.
no, you have I changed the number on the inside, see? I change it to negative 0.001. I change it to 0.001. You can actually
What?
change it. Yeah. Let me show you. And that is how you find the limit using a graphing calculator or Desmos, basically.
How solving it, Mr.?
Hmm?
Solving it.
We cannot solve it without a graphing calculator because you will get undefined without it. Good?
أصدقائي سووا كالكوس هذول اللي جاوبوا خمسات
Yeah.
قالوا ما احتاجني كالكوليتر قالوا ديسموس كان أكثر من كافي.
I mean, look, they took the exam, so I can't really negotiate with them. I mean, if that's their opinion, they're gonna respect
All of
it.
them got fives.
As long as they got fives, then we're gonna take their opinion. If you want, donate that to charity. All right, moving on. Now, given this question, I want you guys to solve it. Now, the hint is never apply the value of -2, because that will give you 0 over 0, which is not okay in calculus. So what do? Whenever you see an x squared term, quadratic equation, always factor. So right now, your job is to factor the numerator and denominator. Please factor. You guys have to be good at factoring, okay?
It's approaching -2, right?
It's approaching -2, but please factor before you answer. Do you know how to factor?
No.
Shit. Okay, x squared plus x minus 2.
X plus 2, X minus 1.
X plus 2, x minus 1. How do you think he knows?
Where do you get the 1 from and where do you get the plus and the minus?
What's 2 made of? What times what? 2 times 1. 1 time put the 2, 1 time put the 1. But be careful with the signs, because your middle term is positive. The positive has to go on the bigger number,
Okay.
and the negative has to go on the smaller number. So x plus 2 and x minus 1. Now, let's take the bottom quadratic equation, x squared plus 5x plus 6. Factor. What's 6 made of? What times what?
3 times.
3 and 2. And how do you get a 5? By adding them. So add.
So inside the number that plus them be 5 and times it to be 6.
Yes. That's called factoring. Right now, if you were to plus them, you will get 5. And if you were to multiply them, you will get 6.
So if I write the 5 and 1,
She's
it's
right.
wrong.
What?
If I write 5 and 1 instead of 3 and 2, it's wrong.
I mean, 6 is made of what times what? Not 5 times 1. Yep, so it's not going to work. Now, time to cancel. And now what's going to happen? Now I'm going to have the limit of x approaching -2, x minus 1 over x plus 3. And now simply apply the -2. So -2 minus 1 over -2 plus 3. That's -3 over 1, which is -3. And that's how we do it.
Mister, the thing is, I'm so bad at math. So bad at math.
You have to just get better, and you have to write the x nicer. Okay. Now,
Like this.
x just looks like this.
But sometimes
Multiplication
you,
sign.
like confuse it with
You put a dot for multiplication in that case. Anyways, how about this one? How do you solve it?
I'll try.
Common denominator for the top is going to be xa, correct?
Mister, why are you okay?
So each example is down.
I have very good book. It's on the drive. You'll see it.
Why is there 2 now?
To what?
Like 2 parts.
Okay. So right now the question is here. How would you start it? What's your method?
I thought I had to do it in Desmos all the time.
Only 1/3 of the test is in Desmos. 2/3 are not. And if there are no numbers, Desmos is going to be useless. Only works with
So what do we
numbers.
do here, Mr. Teacher?
What do we do? We want this to be one fraction.
So you cancel out the minus.
I will just put it on top. So I'm gonna basically open one long fraction and put the minus on top. Now what's x times a?
X.
Ax or xa. That will go on the bottom, correct? So you will multiply x by a and multiply the 1 by a. You multiply the 1 by x and the a by x. And that's how you can have ax in here.
Okay.
So you're going to have a minus x over ax
Which is same as x minus.
over x minus a.
So is it the same as the denominator one or not?
If I right now take the minus out, then yes. Right now, if I keep it as a minus x, I cannot cancel these. Can I? No. But if I am able to take the minus outside, and now the a becomes negative, and the x becomes positive, now I'm going to have x minus a. And now let me simplify. So I'm going to have limit of x over a. This is in math like saying a over b over c is saying a over b times c. A over b times c. And now cancel out these guys. You'll end up with the limit of x approaching a minus 1 over ax.
So where did you get the minus?
Oh, because there's a minus here, and when I cancel it, it becomes a 1, not a 0. Now it's time to replace the x with a, so minus 1 over a times a, so minus 1 over a squared. Yeah. That's fine. Good? She's fine. Next question.
So it's simple, right?
Way too late. Okay, here we have a question. And you're supposed to solve it. Now, if someone here naive replaces the x with a 4, you will get 0 over 0, which means abomination in calculus. You can't factor it yet because you have a square root. Have you heard of the term conjugate?
Yeah.
Good. Whenever you see a square root in a fraction, most likely means a conjugate. So what's a conjugate?
So was it only for the denominator ones?
Mm, not necessarily. No, not necessarily. So multiply the top and the bottom by the conjugate. What's a conjugate? You take the square root component, but simply change the minus 2 into a plus 2 for the top and for the bottom.
So now we got square root, right?
Now the square root will get cancelled in the numerator part.
What happened to 16?
I did not touch it. Not yet, at least. This is called multiplying the top and the bottom of your function by the conjugate, which happens when there's a square root. The sign was negative, it becomes positive. Now, why am I doing this? Because guys, look, if I have a minus b times a plus b, what do you think I will get? A squared minus b squared. Thank you. And so now I'm going to have limit of x approaching 4. So a squared, this is the a, and this is the b. So if a is root of x, a squared is going to be x minus. If b is 2, b squared is going to be 4 over x squared minus 16 times root of x plus 2. Now, I want you guys to use your factoring skills to factor this one into two brackets. You should know what that means. Now cancel.
So,
Okay. So limit kafur, right? That's your word. Kafur.
careful.
Yeah. Root x. Now it's time to replace the x with a 4.
This is 28. That's the 1 over 28.
Sorry, man. This Khan Academy thing is not helping you at all. I guess he didn't teach you this. Yeah. Go back and erase your history from these videos. They're not the best.
قريبة بس 4 طاقة.
Okay, let's explain to you what's happening in these graphs. So look at this graph. What number would you put in the bottom that would make your function undefined in the bottom? 0.
Mr. 0 always equals to undefined.
No. Yeah. If the bottom of your function becomes 0, then yes, it's undefined. If the bottom of the function.
How about if both of them are 0? Still
It's
undefined.
also not okay. Yeah, it's not. It's called indeterminate form. If they're both 0 on top and bottom,
Oh, yeah.
yeah. But if just the bottom is 0, we call this a vertical asymptote, which basically means that your graph is afraid of touching a 0. As you guys can see, your graph is around the origin, around the vertical, x-axis, y-axis, but it will never touch it, right? So a vertical asymptote means you are afraid of an x value. And in this case, it's 0. It will just hover around it. It will go, on top and also on the bottom, but this is called undefined because one is going right and one is going left, or one is going top and one is going bottom. They will never meet, right? If they never meet, we say that the limit does not exist at x equals 0. Whenever your graph looks like this, the limit does not exist. Okay?
But for the second one,
The second one, there's a hole and there is a dot. Let's define what each one means. So, if I say the limit of x approaching 2, I'm looking at the hole. The limit of x approaching 2, it's g of x, I'll write g of x. If I say limit, I'm looking at the hole. When x is 2, how much would the y be at the hole? 2. So you're going to say 2. Good? Limit means hole. But if I just say g of 2,
It's the value.
it's the dot, which is how much? It's a 1. Good?
Mr. Can you repeat?
Sure. So look, in this graph on the right, so whenever you see a hole,
Yeah.
it's the limit part.
Okay.
So right now, if someone says, what's the limit of x approaching 2? You're going to be confused. You're like, wait a minute. Do I use this 2 and I get a 1?
No.
Or do I use this and I get a
Yeah.
2? If it's limit, that means the hole.
Okay. What about the other one?
If they just say g of 2, they mean the dot, which is equal to 1.
Okay.
So right now, the limit of x approaching 2,
so limit means the hole is empty, and
hole just means emptiness, yes,
g of x
is the dot. Limit is 2, and when it's a dot, it's a 1. Are they equal to each other?
No.
No. This is not continuous. And whenever you see a hole on a line, it's called removable discontinuity. whenever the hole is on the line and the line extends, on its left and on its right, it has this name. Something had to be removed at some point for the hole to exist. Good. Now, this is called a piecewise function because a gx could be equal to multiple prompts. So the gx is equal to x if x is not equal to 2, and it's equal to 1 if x is equal to 2. Okay, is it confusing? No problem. This is called a piecewise function. What does that mean? You have this, and you have multiple things inside, 2 or more. Now, someone is going to say, what's the limit as x approaches 2? What would you say? Would you say this or would you say that? Because it does not equal to it, that's limit. It's approaching it, but not equal to it. So right now, if they say the limit of x approaching 2, you say, okay, I guess I'm dealing with the first prompt, which is x.
But sir, we can't choose the second one because it's already 2.
Thank you, it's already equal to it, so it's no longer a limit. And when x approaches 2, just replace the x with a 2. So right now, if someone says, what's the limit of x approaching 2?
X.
You say, it's x, and just replace the x with 2, and you get 2. Okay. What if...
So we get 1.
The first and second one?
Why?
Don't we get 1?
No, if someone says, what's the g of 2?
Okay.
You say 1. Good? Very good.
لو نسوي
I'm stressed.
5 minutes نسوي شلون driving.
I know. Now, I will allow you to use Desmos for this one. Just to see what the graph looks like at least.
Sir, Desmos alone needs like a lot of practicing to learn.
Because you have a phone. So the function was y is equal to x over the absolute value of x. Look at the graph. Look at the graph. So, see? It says 0 for the x, but undefined for the y. It says 0 for the x, undefined for the y, correct? Do you see how it's a hole?
This doesn't.
Do you guys see the hole?
exist, right? 'Cause
Thank you. Wait,
They don't match.
1 second. It's a hole now. A hole means undefined. Okay?
Even the graph listed, they're not.
It is touching it. It is. I mean, can you say it's not touching the
Sir,
one?
where do you get the line between x?
So yeah, now we can tell that.
They're
And
just
if you want-
straight lines.
Yeah. But are they physically touching each other?
No.
No. You see, this is called the left hand limit, and this is called the right hand limit.
Also, you said that the graph, the lines don't touch each other, it does not exist.
Thank you. So because the two lines are different and they don't physically touch each other, we say that the limit does not exist.
So, for example, I see 2 lines
Negative 1?
that are not touching, so it does not exist.
Exactly. So the limit at x approaching 0 does not exist.
Sir, what does LHL stand for? Left hand?
Left hand limit versus right hand limit.
Okay.
How would this appear in the exam? This is how it's going to look in the exam. They're going to have a hole, which we saw in Desmos, it was undefined. And also, no, they don't touch. That's called jump. If they don't jump, if they don't touch, it's called jump. And that's when the left hand limit is not equal to the right hand limit. And that's when the limit does not exist. So if there's a jump, if there's a cut in the graph, Let's show you how to do this now without Desmos. So look, I can do this from left-hand limit and from the right-hand limit. So x over and x over. The game is in the absolute value. If you're doing left-hand limit, you make the absolute value into a minus. And if you do right-hand limit, just remove the absolute value without the minus. This will never change.
So can you repeat what you just said?
Definitely. If we say left-hand limit,
Yeah.
that means your absolute value is going to be negative.
Okay.
And if we say right-hand limit is going to be positive.
Absolute value is the 2 line, right?
This is the absolute value. One time it's negative, one time it's positive. Now I want you guys to simplify this one. How much will you get?
1.
No. -1 versus 1.
So what about
Yeah, the one down is.
No, we removed it.
Oh, okay.
Once you do left hand, right hand, absolute value disappears. And that's exactly how we got -1 on the graph and +1 on the graph. If you guys recall the graph, it was -1 and +1, correct? Good. Let's do more. Actually, before that, so now because the limits don't match or don't equal
So
each other, we say the limit does not exist. Good. Let's do more. Here's the function. I want you guys to find the limit of x approaching 2 from the right. When I say that, do you guys know what that means? The absolute value becomes positive. Like just copy paste what's inside the absolute value without changing the sign. That's what plus means. It just means right hand limit.
Right hand is the one with positive
No.
sign?
did you just
Yes.
say, Mister? Can you repeat what you just said?
Yes, guys. If it's absolute value
Yeah.
and if it's left hand limit, that means put a minus sign on whatever was inside of it.
Okay.
But if it's right hand limit, just copy paste what's inside without changing its sign.
How would we know which one is left-hand limit and which one's right-hand?
If they say to the power of plus, that means right hand limit.
Power of negative, left.
Power of negative, left hand limit.
So would also be 1/5 and -1/5.
So can you box are correct now?
Yes. Now, right now we're dealing with the right hand limit. Who taught you that? Don't mention his name.
I second it out.
Yeah. Whenever you have a quadratic function, it's your job to factor it. Factoring is a good skill for the AP.
So, Mister, the up one is left-hand.
No. Look. Let me just tell you something. So here's x plus 2. I mean, sorry, x, let's just say -2, okay? Now, if I say left hand limit, that means you put a minus sign.
Okay.
And if I say right hand limit, that means you just copy paste it.
Okay.
But in the exam, they're not going to say find left hand limit or right hand limit.
What will this?
They will say find the limit of x approaching 2 to the power of negative.
If it says to the power of negative, we.
That's left hand limit.
Yeah.
And if they say to the power of positive, that's right hand
Okay,
limit.
Mister, can I copy this?
Yes. Yes, please. Now let's factor to find the right hand limit. Factor the bottom of the equation. Could you guys? You must know how to do it, huh?
X minus 3 x plus 3.
X plus 3, x minus 2. How did he know?
I don't know.
By the
Look.
other side, Mister.
Hmm?
Those on the other side.
No. This side, that
Mister, can you go down so I can finish copying this?
Note what done.
This one's written this.
So, do you know how to factor or not?
One of them is
Look,
three.
how did he know it's a 3 and a -2? What's 3 times -2? -6. Actually, I like him. I don't mind him. And 3 minus 2, he's actually their teacher now. And 3 minus 2 is plus 1.
He's good. Do you like him?
Alright, and now we can
Yes.
cancel. Thank you, cancel. So now we're going to have the limit of x approaching 2.
If I do good in factoring, class, I'm good. Factoring is my dad.
You must do the blueprint that I told you about.
So blueprint teaches me how to do everything.
No, it tells you what to do to stay on pace so you don't freak out when April comes.
I'm gonna freak out.
No, it's going to make you unfreak out.
بس الرسم ماشي بس ما خليش في البلوك.
Now let's find the left-hand limit. That means limit of x approaching 2 from the left. So now what do? You put minus on the absolute value. And I want you right now to correctly factor the bottom of the function.
Plus 3 and minus 2.
Smart man. See, he knows now.
I'm just
I wish it was that
writing,
simple.
Mister, by the time I finish writing, you guys finish solving like 2 other questions.
Why are you writing?
Right that.
Exactly. Or don't write.
Okay, let me just
Right
finish
and
this.
2.
So minus 1 over 5. So look right now. Left-hand limit and right-hand limit. Are they the same as each other?
No.
No. So now if someone says, what's the limit of x approaching 2? What do you say? Does not exist.
Why? Because the answers are different.
Yes.
بس خليج شيء.
Okay, I know that.
Jump discontinuity. Oh, they're so good. They love them.
وينها؟
They are there.
بوكس لا خليجيز.
Khalichis. It's not a book. Not yet. He's a permanent resident now. He's got a green card.
Do you
Or
shop for all
Khalichis
of
card.
these snacks?
Now, please solve this one.
You need to make it into positive and negative. Because why you have this thing?
See, overthinking made him lose the point.
Yeah, actually.
He was so proud of himself.
Is that right?
Just replace.
Total 5.
2 times 2 plus 1. And you get the root
I would
of
say
5.
replace for the since beginning. You say factor. You say.
I said that? I'm not so sure I said that, but whatever makes you sleep at night. Good. Excellent. Moving on to something a bit. Actually, you know what? Let's try your factoring skills. You know what? This is like the ultimatum. Do this one, please. Whenever you see quadratics, that basically means you must factor. You must essentially have.
Mr. Dosso,
No, I'm just gonna
As it's approaching 5.
like this. Yeah.
But for which part? For,
I don't understand your question.
like for 15 and 10, right?
Yep.
Oh, Mr. This is easy.
بس نفس.
What
5 times 3
5 and 3.
plus 3 and negative.
Let's put the signs in the end. How about the 10? 5 and 2. The signs on you, Mirva. The signs on you.
Sir, I told you what to do.
The signs on you. Okay, so the top one is what?
Positive.
Negative, negative, thank you. And the bottom one? Negative, positive, thank you so much.
I got the numbers except the signs, but it's working, Mr. No?
Here we.
Oh my
Wait,
god.
Mr. Stay, don't.
Hate that one so much. Alright guys, so look. Let's cancel these guys. So we get the limit of x approaching 5, x minus 3 over x plus 2.
Then you do 5 minus 3, then 5 plus 2,
2 مثلا.
2, you're 7.
And by the way, now we removed the x minus
So
5.
where'd you get x minus 3, x minus plus 2?
This is the factoring that we did. We removed it, right? Now please equalize it to 0. How much would the x be? So it's going to be removable discontinuity.
How did you get 5 plus 2?
I just transferred negative 5 to the right side and became positive 5.
But it was not negative 5, it was 5. The limit is 5. X approaching.
No, I'm saying, what did we remove? We removed this guy, right?
Yes.
Take it, equalize it to 0, move it to the right side, becomes positive 5. And let me prove it to you.
Mister, limit does not exist.
Why? What's that then?
Oh.
Good try. Now let's use Desmos to show you what that means. Guys, look. So on the graph, it looks very normal, right? But guess what? Right now, if you go here on x equals 5, see that? You guys see it?
Yeah.
Undefined. And there's a hole. And if you want, just come here and do the table and put a 5.
But there is no jump.
Undefined. There is no jump. Thank you. So it's called removable. And you're gonna have a hole at the 5. A hole.
If there's a jump, you can't remove it. If there's no jump, remove it.
If it's jump, you will see two different graphs.
Yes, that's.
If it's one graph, it was removed. Thank you.
And limit exists.
Limit exists. Thank you.
I'm getting it.
It was equal to 2/7, I
I'm
think.
getting there. I'll practice so much at home. I'll make you proud.
We got something new for you called the squeeze theorem. Yep, it's called the squeeze theorem because we are squeezing two functions. I mean, one function between two
I think I
functions.
studied this today.
You think?
Why would you think you studied it today?
So you don't know or you know? We're squeezing one function between two functions. Let me ask you, which one is being trapped
The
between
red
two
one.
functions?
The red one.
Thank you. Is being squeezed between h of x and f of x. Now, how would we express this in calculus terms? The function that's in the middle is bigger than or equal to
I still have studied. I did this today.
what's below?
You said g of x is in the middle. There's h of x and the other one. You do two sides.
Thank you, thank
Yes,
you,
I've done
thank you.
this.
The limit of x approaching a for f of x is same as that for the h of x, which would basically means that g is the same. So if this is approaching 2 and that's approaching 2, g will be also approaching
Two.
2. That's the idea of the squeeze theorem.
Mr. Recap. Recap.
Recap. If the number on the left and the number on the right agree, then the middle number will have the same exact number. Like if this is 3 and this is 4, the
No.
theorem doesn't work.
Does not exist.
Yes, they must be the same exact number.
I studied this today.
Good. All right, guys, new question for you. So, I want you to use the squeeze theorem to evaluate the limit of x approaching 0, x squared, sine squared,
So please look at this.
1 over
The
x.
student only said one sentence. She answered by 3 paragraphs.
No, I'm not supposed to laugh at this, but I want you guys to use the squeeze theorem to solve for this guy. Now, the first thing I want you guys to
Calculator.
I want you to first look at it in terms of Desmos. First thing first, go to Desmos, just like for you guys to imagine it, and I want you to graph sine squared of 1 over x just to see where it ranges from where to where. Just to see. Because trig is a bit tricky. Trig stuff is a bit tricky.
Sorry, I don't get how to use this.
Okay. So guys, go to Desmos and you will type sine of 1 over x, but don't forget it must be squared
Where's sign?
Where is it?
in functions.
Okay.
Sure.
But don't forget it must be squared, right? So I'm gonna write squared here. Nice. Is it squeezed between 0 and
One
1?
in the middle is g of x.
Just 1 second. Is it between 0 and 1? Is it between 0 and 1? Do you guys see the 1? I see it. I don't know about you guys, but I see it.
It's between -1 and 1.
No, it's between 0 and 1, you mean, right?
Yes.
That's what you meant?
Yes.
Good.
But isn't it between 1 and -1?
Do you see a -1 on the graph? When the x is approaching 0, look,
Oh, okay.
when the limit of x approaching 0, that means here. It's ranging from 0 to 1 on the y-axis, correct?
Yeah.
Yes or no?
Yes.
So now we know that it's going to range from 0 to a 1, correct? No. Do you see this part of the equation? Good. I want you to multiply this and this and this by x squared. So what's x squared times 0? X squared.
By x squared.
Thank you.
But that's good.
Okay,
So let's do it by numbers.
Şey,
we're gonna start right now.
What do you mean by numbers? So what are we doing it now?
bir saat bu.
Numbers are not good.
No, I didn't say. X is approaching 0.
Çok kısa.
No, I just said 45 for you to know in case someone's picking you up. Did you come by car? That's right. She came without a car. You came without a car. Carless. Now look, I'll drive you home if you guys want. Where do you live?
It's very
My parents are
Oh, that's good. Okay. We'll
So
order
I
you.
got other places to be at after.
Oh, you're not gonna go home and study?
I have to go to the stationery.
That's cool. Nice adventure. So x approaching 0.
I have to get no start.
Replace the x. Okay, if x approaches 0, what's 0 squared? 0. So what's going to be our answer then?
0.
0. It's squeezed between 0 from the left and 0 from the right. Our answer is going to be a 0. How nice is that?
nice.
Very nice. What do you see in here?
I see limit exists.
1 second. When the look when okay, 1 second. As x approaches infinity, what does the function approach?
1.
1.
How are we supposed to know that?
Infinity means positive numbers.
Okay.
As x approaches negative infinity.
Negative 1.
Negative 1.
Wow. Okay,
So are you recording?
everything. Do you know what these are called? These dotted lines? Horizontal asymptotes. Yes, we have a horizontal asymptote. And we also have here another horizontal asymptote. One is equal to 1 and one is equal to negative 1. Why is it called that? Because it's dotted line and it's horizontal. Good?
Yes, sir.
Yeah. I just saw something that, I don't know.
I don't know.
So, I don't know, I saw something very suspicious. So when limit of x approaching infinity is equal to 1, and the limit of x approaching negative infinity is equal to negative 1. This is called horizontal asymptote definition.
So for the squeeze, can you do?
I also keep hearing noises.
Here we have something new. Here we have the limit of x approaching infinity. When x approaches infinity or negative infinity, what you do is you divide everything in the numerator and denominator by the highest power of x in the bottom of the function. Sure. Whenever you have the limit of x approaching infinity,
Yeah.
you divide every single number on the top and the bottom by the highest power in the bottom. Highest
five.
x power.
Five.
No, highest x
Three.
power.
3.
Highest x power. No, x squared.
Yeah.
X squared. So divide all by the highest power of x in the bottom of the function, which in our case is going to be x squared. So go ahead, divide all of them by x squared. So 2x squared over x squared minus x over x squared plus 3 over x squared, 3x squared over x squared plus 5 over x squared. Now just a general question, general knowledge question for you. What's a number over infinity equal to?
Infinity.
I was going to go with a 0 maybe.
Wait, mister, can you repeat the question?
Yes, right now if you divide any number by infinity, you get a 0.
Yeah.
If you want, try in the calculator, divide 5 by 10 to the power of 12. You will get a 0 probably.
Right? Over what?
Huh? Divide 5 by 10 to the power of 12. I'm assuming you'll get a 0.
You're mistaken, sir. 95?
Okay, very small number. That's like almost a 0. Just say a 0 in math. So,
Mister, is that the answer for?
no, no, look. Cancel the x squared with the x squared, and the same happens here. Cancel x with the power. So you're going to have limit of x approaching infinity minus 1 over x plus 3 over x squared. This is a 2, right? This is a 3 plus 5 over x squared. Now, whenever the bottom is a bigger power, which is happening here, a 5 over infinity or a 3 over infinity or 1 over infinity all give you a 0. Okay? So now we'll get 2 minus 0 plus 0 over 3. Sure. So look, if you divide any number, which I will call k, by infinity, you get a 0. And guess what? X is approaching infinity. So what's the answer going to be?
0.
2 over 3. Yeah.
I need a little practice.
And by the way, this rule applies because the top and the bottom were of the same highest power. Okay?
Yeah.
Now, let's see what happens if the top and the bottom don't have the same power. Still divide. For example, if I have limit of x approaching infinity of 5x plus 2 over 2x cubed minus 1. Again, divide every single thing by the highest power of the x in the bottom of the function, which is how much? X cubed. So divide everything by x cubed. That's the highest power,
I see a 0, no?
most likely.
امسك الشيء ما جبتش.
For a q requires the work.
عامل حالي امسك كيو خليني قاعد.
Sir, this recorded lesson, could you please send it now so I go home? I study them and.
Right this moment. Right this moment.
Thank you so much.
This will cancel. Whenever the power in the bottom is higher and it's approaching infinity, the whole thing becomes 0. So you're going to have 0 plus 0.
It's not high.
X cubed is higher than x.
It's 2x power 3.
What?
Yeah, 2x.
No, I'm saying
3x.
this
Oh, okay.
becomes 0. This becomes 0. This is a 2 and that's a 0. So the whole thing is 0. So now it's an MCQ rule if you want. Whenever the numerator,
So where did you get the 2?
oh, because 2 here and the x cubes cancel. Whenever the numerator power is less, the whole thing becomes 0. Because this is x. It's less in power than x cubed.
Yeah.
Definitely. If the question says, find the limit of x approaching to x squared. That's an example of a polynomial function because there's no fraction here. All you do is you replace the x with 2 and you get 4. Let's say, for example, we have limit of x approaching 1, x to the power of 3. Just replace the x with 1 and you get 1. That's an example of a polynomial equation. Let's give you more. Limit x approaching 2, x squared plus 4. Again, just replace the x with a 2. So you're going to have 2 squared plus 4, which means an 8. So far, there is nothing that's too hard. Okay? But things will change once you come across a rational function. So, let's say, for example, I have here limit of x approaching 5, x plus 3 over x squared minus 15. The first thing you think of is what happens if I put this 5 in the denominator? Will the bottom of the equation become 0? Because if it does, you want to avoid that as much as you can if you could. Right now, if you put that 5 instead of the x in the bottom of the equation, what happens? Does it become a 0? No. You will get 5 plus 3 over 25 minus 15. That means you will get 8 over 10, which is 4 over 5. See, it's perfect here, because putting the x of 5 in the bottom of the equation did not give you a 0 denominator. Your life is easy if it's like that. What if it does? What if it does though? For example, if I have limit of x approaching 3, x squared minus 9 over x minus 3. Right now, if I were to replace the x in the bottom with a 3, I'm going to end up with a 0 in the bottom, which is to be avoided as much as you can. So before you replace the bottom and get a 0, try to be able to remove that x minus 3. You want to remove it. If you could remove it, it's perfect. Let's see if that's possible. So look, the x minus 3 stays the same, but the top of the equation can be changed into something else. Are you aware of the rule of a squared minus b squared? Do you know that?
I forgot everything about that.
Okay, it's going to be equal to a minus b times a plus b. That means if I have x squared minus 9, it's going to be x minus 3 times x plus 3. So now I'm going to replace x squared minus 9 by x minus 3 times x plus 3. So now these will cancel. You will get x plus 3. And now replace the 3. So let's just erase that one. So now you will just say you have limit of x approaching 3 for the remainder. And now replace the x with a 3 and you get 6. Now if you're confused about how x squared minus 9 became x minus 3 times x plus 3, ask yourself, x squared is made of what? Of x times x. And 9 is made of what? Of 3 times 3. That means if I have x squared minus 9, it will be x and then the other x, then 3 and the other 3. But one time minus, one time plus. And now this one and this one are both x minus 3. They will cancel out. By being able to cancel x minus 3, so we canceled x minus 3, we have what we call a removable discontinuity at, if you were to equalize x minus 3 to a 0, how much would the x be? 3 or negative 3?
Negative 3.
No, right now if I take x minus 3 and I equalize it to 0, x will be equal to 3. That means we have this discontinuity at x equals 3 because it got removed. It got removed. Okay? So now what do we say? We say that the limit exists. We say the limit is equal to 3. Now, because we were able to remove x minus 3, we have what we call discontinuity that's removable. Okay? Now, in the exam, this might be represented as a hole. So if you see a hole of this type, we're looking at that discontinuity. But right now, if you go to Desmos and graph it, you will not see any hole. No hole is visible in Desmos. Let me show you. Let's do x squared minus 9 x minus 3. You see, when x is 3, which is here, there's no hole. There's no hole. But if you want to know if there's a hole or not using Desmos, I recommend using the table functionality. Let me show you. So here you can actually go to table, create table, and right now if you put 3, you get undefined.
What's undefined?
It means it does not exist at 3. It means there's a hole at 3. So there's a hole at x equals 3, which is why now the graph will not show you the hole, but the table is going to tell you there's a hole by telling you it's undefined. Removable discontinuity. Okay. Okay. Now we have something new for you, okay, which is called a theorem. We have 3 theorems in AP Calculus, okay? The first one is here. It's called the intermediate value theorem. I want you guys to memorize the theorem. So here it is. The function is continuous on a closed interval. Using those square brackets means we have a closed interval. Now, there is a number, which is c, okay, between f of a and f of b. Okay, so a is less than c, is less than b, and f of a is less than f of c and less than f of b. Okay, so what does that mean? For example, let's say my function is from 1 to 5. Okay, so and let's say that when x is 1, my f of x is negative 2. When x is 5, my function is 10. Pick a number between 1 and 5. 3. So that means when x is 3, f of 3 is going to be bigger than negative 2, but less than 10. Because 3, you see 3 is between 1 and 5. So f of 3 is between negative 2 and 10. That's called the IVT theorem. The function has to be continuous. Only continuous. Okay? For example, let's say here we have the xy coordinate, and this is the a. Let's say it's negative 5, and let's say the b is a 6. And let's say that this is the f of a, which is the y value, which is negative 3. And let's say the f of b is here, the y value, let's just say it's 5. So the f of A is negative 3. The f of B is a 5. What should if C is somewhere between negative 5 and 6, let's say that C is here, a 1. F of C has to be ranging from negative 3 to 5. That's what it means. Good? So basically, as we go from negative 3 to 5, we have to pass through the 0 point. So if you start negative and you go positive, you are required automatically to hit the 0 at some point, to hit the axis at some point. Okay? Yes. So with that in mind, let me give you a tiny question. Okay, ready? So let's say that I have x cubed minus x minus 1, and let's say it's equal to 0. The interval, closed interval, it has to be from 1 to 2. Okay? I'm going to be asking you to, first of all, find the f of 1. Okay? Find the f of 2. Start by doing that.
Negative 1 and
Negative 1 and 5. So basically the A is the 1, the B is the 2. Okay. F of 1 is negative 1. Okay. And F of 2 is 5. So as you go from negative 1 to 5, don't you have to hit the x-axis? So that means that C is between A and B, and f of C has to be between negative 1 and 5. It could be 0. We applied, or he applied. One time he put x as 1 in all of them, and one time he put a 2, and I guess he used the calculator that's in his head somehow, and he got it. Yeah. So can I say that f of C is going to be 0? Of course. Because how would you go from a negative value to a positive value without crossing the x-axis? F of C has to be 0. This is called the 0 of the function, or the root of the function, basically.
You have to write a sentence with it, right?
Yeah. Whenever there is a theorem in calculus, you must write the full sentence. Okay? You must say the function is continuous on a closed interval. C is between A and B. You must say the numbers. Therefore, f of C has to be between f of A and f of B. You must also say the numbers.
Can you say it passes the intermediate value theorem?
I mean, you could, but I haven't seen that. You just say,
In our school they did that.
oh, I'm sure it's right. Okay. So here, x cubed plus 3x minus 7. I want you guys to graph it using Desmos. Okay. And I want you to tell me f of C is equal 0 at what C? That means at what point does your graph hit the x-axis? Click on the dot where it hits the x-axis. X-axis. X.
1.4.
1.4?
Yeah.
What dot?
This one.
Not that, like the place where it hits the x-axis. Okay.
There's no dot.
Now, let me give you a question based on that. Ready? Let's look at this question. The IVT guarantees a value C where f of C is equal to 0. Look guys, for the f of C to be equal to 0, that basically means we have to start negative and we have to go to a positive. So now what do? I want you guys to apply to this equation -1 and see how much you get. Apply 0 and see how much you get. Then apply a 1 and see how much you get. Like make a table. When x is 0, when y is equal to whatever. So -1, apply it. 0. So -1, 0, 1,
Certain
2.
x power 3.
Yeah. That's x cubed plus 3x minus 7. Go ahead, try it. Apply the x's without using a calculator. Tell me the y values, please.
It's -11, -7, -3, 7, and the last one I didn't do it because I figured out the answer.
We go from -3 to 7, right? And this happens as x goes from 1 to 2. And you guys, when you graphed it, didn't you guys get 1.4?
Yeah, we did.
Which is between 1 and 2.
So how do you know that's between a negative and a positive one?
Between -y and a positive y.
How do you know that?
Well, what do you mean?
So wait, in the exam, you can check the x-axis and directly know the answer?
Yeah, but that's too generous.
Sir, can we take a break?
From what?
Studying.
See, guys, we went from 1 and -3 to 2 and 7. So you had to go through the x-axis, which you guys said was 1.4. Exactly. All right, guys, look. Again, 0. You know what that means? We have to go from negative to positive. So find where the f was negative and then goes to positive. So try the x values.
Can this part be with or without calculator?
No calculator, please. You must know these without a calculator. That's exactly true.
بس ليش ما يعطوني unit circle?
They can't. All right, guys. I'm assuming you don't know what sine of pi over 6 is, do you?
30, right?
Yeah, so what's sine of 30?
Wait, it's 1/2?
Wow, that's actually hard. Okay, what's the sine of pi over 4?
45.
Yes, which is how much? Your neck is gonna hurt.
Radical 2/2.
Yeah.
Yes, which is 0.707. Very good. So 0.5. Don't get confused. Okay. How about the sine of pi over 3?
Square root of 3/2.
Which is?
Do you have to know the decimal?
No, it doesn't matter, I think. Wait, sine of 45.
بس ما كان which sort of the
Sine of 60 is 0.866. Actually, just keep it in like fractions if you want. Like this way if you want. It doesn't matter.
But I think it's harder.
How about pi over 2?
1.
Sine is 1. How about the sine of 3 pi over 2?
-1.
-1. Because look, this is pi over 2. That's 3 pi over 2. Here sine is 1. Here sine is -1. So look, going from here to here meant from positive to negative. So we're going to go from positive to negative. We have to hit the x-axis. That means the f of c is 0 as we go from pi over 2 to 3 pi over 2. Yeah? Wow.